Now that we've had that refresher on network hardware and talked a little bit about visibility windows, it's time to get down to the business of discussing the capture methods you'll actually use in practice to collect packets so you can analyze them. To that end, we're going to talk about four different techniques: the use of span ports, network taps, the hubbing out technique, and the software-based technique of ARP cache poisoning. Between these four techniques, I think that's going to cover nearly every scenario you're going to face in terms of how you want to collect packets on the network. Now, in this case, I'll describe each method and how it works, and in a couple cases, I'll do a quick demo where that makes sense. I'll also talk a little bit about when it's a good time to use each technique and when maybe it's a bad time. That said, I'll also save some of that discussion for the end when I'll actually go through a flowchart you can use to make a decision about which capture method is most appropriate for the scenario you're currently facing. The first technique I want to discuss is the use of a span port. And I use the term span, but this is also something that's called port mirroring. And I'll kind of use those terms interchangeably. I know folks who are accustomed to using either term. I tend to use mirroring more, but span port I think is the more proper term. But nonetheless, what we're talking about here is the ability to use a network switch to logically replicate traffic from one port to another. And I have a diagram of this here. Now, if you remember our visibility window diagram earlier from when we talked about what it looks like when you're connected to a switch, you know that if you plug a sniffer into a switch, you can only see the traffic to and from your sniffer. You can't see anything else. Now, the creation of a span port allows us to use the software on a switch to tell it to take the traffic to and from an individual port and mirror it to another port so that anything plugged into that secondary port can then see the traffic to and from the host plugged into the primary port. So in this case, what we have in this diagram here is computer A's port mirrored to the sniffer port. So all the communication to and from computer A is being mirrored to the port that the sniffer is plugged into. Therefore, when the sniffer fires up the packet capture software and starts capturing packets, it'll see everything to and from computer A. So it's a one-to-one mapping of that port, the source port, to a destination port in which a sniffer is attached. Now, there are a lot of benefits to this method. One is that it's pretty easy to pull off. Oftentimes to configure it, it's just a matter of logging into the switch, picking a source port, picking a destination port, and hitting apply, and then actually plugging your sniffer system in, and you're good to go. Very straightforward, pretty easy. Often you can do this in a web interface. Sometimes you're doing this via the command line as well, though. Now, it's important to note that this is only on smarter switches, so to speak. So many of your cheaper home switches, your $50 D-Link switches or things like that you might find at Best Buy, those are not going to have the ability to mirror ports. Some of them will, but for the most part, those home switches will not. You're really going to find this mostly on enterprise level switches and even some of the intermediate office level switches. You'll find this capability, but you will find it on most of those smarter switches. And when in doubt, just check the documentation of your switch. If you know you're going to be doing packet capture, and I think certainly most people could benefit from it, then you want to make sure you're purchasing switches with this capability. Nearly every switch that has this capability will mention it in its specs sheet, and any of the websites you're buying these things from should have a section which lists whether port mirroring or port spanning is capable. Sometimes they'll call it port monitor mode. They'll use that terminology as well. So that's something to look for too. But generally, you should be able to find that, and I recommend buying switches that do have this capability. If you're talking about your home network or a really small business network, there are certain brands of switches that are cheaper, like less than $100, that will provide some level of port mirroring capability. I have two sitting right beside me right now. I have a Netgear switch and a Linksys switch that both provide that capability and that both cost less than $100. So there are lists of those that you can find out there just by Googling low cost or cheap mirror port switch. So those are definitely out there. So the hardware is definitely something you can acquire in most cases. Now, a couple things of note. One in particular is that you have to really be wary of overtaxing your switch. Switch has its own processor, and anytime you mirror traffic from one port to another, it's taking it's taking away some of the performance of that switch. It's requiring some of that processing power to do that. So if you set up a lot of port mirroring, if you mirror a lot of ports to a lot of different other ports on a switch at once, and there's a lot of throughput, it could negatively affect the performance of your switch. It may slow down your clients who are connected to it, or it may actually cause you to drop packets in the packet capture process, which we certainly don't want. That's kind of the enemy of our packet capture process, is when we're dropping packets. So you have to be concerned about that. The other thing you have to be concerned about is the physical limitations of each individual port on the switch. For instance, if you have a gigabit switch with gigabit ports on it, that means theoretically the limit of each port is a gigabit of communication. So if it's a 24 port switch and you take 23 of those ports and mirror them to a single port, you're basically at risk of overloading that port very easily. Even a little bit of traffic across the board, and you'll very quickly overload your switch. You'll overload that port. So, and that's an extreme example, but it can also happen in smaller examples as well. So port mirroring doesn't have to be a one-to-one endeavor. You can mirror multiple ports to an individual port for the sniffer. And I've seen many cases where someone will mirror 3 or 4 ports to an individual port, and that's honestly too much traffic in some cases to be handled by an individual port, and the sniffer ends up dropping packets, and bad things happen. So generally, I don't recommend using a span port for anything more than 1 or 2 ports at a time. And even then, if you're using more than one, you really need to make sure that they're not both at a consistent or peaking high performance level where you're going to drop packets. So that's something you really have to be concerned about. Now, port mirroring is really useful when you already have the technology to do it. So if you already have switches in place with this capability, this will allow you to capture packets from a system without installing any software on it. You can actually just log into your switch, mirror the port over, and if you already have your sniffer plugged into the destination port, the recipient of the mirrored traffic, you can start capturing packets without interacting with the target computer you're concerned about at all. No interaction whatsoever. So that's really great. And that kind of speaks to another benefit of using a span port, in that you don't have to touch the system you're inspecting if you are indeed inspecting a single system and the traffic to and from it. That means you don't have to install any software, you don't have to bother a user, none of those sorts of things. So there's a lot of scenarios where that is desirable, especially again when you don't want to bother the user, you don't want to maybe take a sensitive or high priority system offline, or maybe the system is you're convinced it might be infected and you don't want to log into it or try to install software or anything like that. So very useful in those situations. There are a couple situations where a span port is not the most useful. The first of those is when you simply just don't have the technology to do it. If your switches don't support port mirroring, then of course you can't participate and you can't do this type of method. So that's something you should be aware of before you try to do it, or you're going to end up feeling pretty frustrated there. So you can't do it if you don't have switches that don't support it or have the ability to use those switches. And the other scenario where using a mirror port is not the most useful is when you expect really high throughput through the device that you're going to be looking at. So I've already talked about this a little bit. Even with a 1-to-1 port mirror, you could expect to maybe lose just a little bit of performance just through nature of the mirroring process and the processing overhead. But especially if you're doing 2 or more ports and you're expecting high throughput, then you're going to very quickly overload the individual port you're mirroring to. So you have to be concerned about that, and that's the scenario when a span port is not going to be the most useful thing. And I can say from experience that when a span port acts up, when it's not working correctly, that's a very frustrating thing, because the way that manifests is via dropped packets. And oftentimes you won't know that packets have been dropped until you're actually investigating a problem. And most of the time when we're doing packet analysis, we're not actually stepping through every single packet. We're looking at statistics, or we're looking at graphs, or we're viewing conversation summaries and things of that nature. And since you're not going through every packet, it may be a little difficult to determine when a individual packet or a couple packets are missing until you've already wasted a lot of time. So a malfunctioning span port or an overloaded span port is a very frustrating thing, and it can end up wasting a lot of your time, and you certainly don't want that. So again, you want to avoid high throughput situations when you're utilizing span ports for capturing packets. That said, when you're just looking at an individual host and you have the technology available, span port is really, I think, one of the best methods you can use for packet collection. So I highly recommend it in that regard. And I would certainly recommend, if you have switches that are capable of it now, playing around and trying to figure out how to do port mirroring, how to set up a port mirror on those, and doing a little experimentation of your own. Next, I want to show you a little demo of what port mirroring configuration could actually look like. So I've set up a little scenario where we're going to kind of explore this using an actual, just a simple home 8-port gigabit switch, which I have set up here. You see on the left-hand side of the screen, I have web-based administrative access to my Linksys switch, which supports port mirroring. And then on the right, I have a couple other things going on. Right here on the top, I have a ping going. So I'm pinging 8.8.8.8 from a host inside my network, just a random host. And then over here, I'm logged into a network sensor, which is configured to capture packets using TCP dump. So I'm capturing packets here from a monitoring interface, which is plugged in to my switch, and I'm filtering only down to ICMP packets. So what I want to do here is set up a mirrored port such that I'm able to capture the packets that I'm causing to be generated here in this top window. So if done successfully, here on the bottom window, we'll actually see those packets being captured using TCP dump. Now in this case, you'll see there's a picture of the switch here, and the ports where there are green lights are where things are plugged in. Now, the upstream link in this switch to my external router is plugged in this port 1, also known as GE1 if I hover over it. So port 1 is actually going from everything else on my network, is going through this switch, and to go to the internet is going through port 1. So to physically get to the internet, this ping that I'm sending up here is actually going through port 1. Now, to get traffic, what I'm going to do is mirror port 1 over to port 8. And port 8 is plugged into my sensor, which is my sniffing device, and that's what's represented on this lower right-hand window here, this Linux host that I've SSH'd into. So I'm going to mirror port 1 to port 8. Now, to do that, we're going to go over here to this maintenance tab. This particular Linux switch puts that configuration option under maintenance and under this port mirroring heading. Now to set up the port mirror is actually pretty easy. I'm just going to click add here, and I have to pick a source port and a destination port. I said I want to mirror port 1 to the destination port of 8. So source port 1, destination port 8, and I want TX and RX. So I want transmitted and received packets. I want bidirectional communication, and I'm going to apply that. And what do you know, the second I click apply, we see packets coming through. So my ports are actually mirrored now. And if I go back to this system status tab, it's going to look the same, but just to reiterate, every packet seen on port 1, transmitted or received, is now being mirrored to port 8. My sensor is plugged into port 8, so I'm now seeing those packets. As a matter of fact, I'm going to see any packets at all that are transmitted upstream from my network now that I've enabled this. Of course, in this case, I just have, this is a constrained scenario, and I'm just limiting this to the echo, request, and reply, the ping packets. But this gives you an example of how you might configure a port mirror on a switch. It's going to look different in every switch you try to do this in. So it's going to look different in a Linksys versus something that's a bigger Cisco product, or D-Link, any of those other products. They're going to have their own way of doing this, but generally it is going to be identified as port mirroring or port spanning or something like that. And for that matter, you may not always do it in a web interface. You may do it in a command line interface or in some type of configuration file, but nonetheless, this is a feature of many switches, especially your enterprise level switches. But in this case, we just did this on a Linksys home switch that demonstrated this port mirroring, port spanning capability. I want to take a quick detour before we go into our next packet collection technique. And I want to take that detour to talk about promiscuous mode because I said something earlier when talking about switches that may have made you a little bit confused when we talked about port mirrors a second ago. The thing I said is that packets that are not destined for a specific host are often dropped by the NIC. They're dropped by the network interface card. And I showed this image on the screen. And this is the visibility window for when you're connected to a switch. So when you're connected to this switch, you're only going to see traffic to and from the connected device, which in this case is our sniffer. You're not going to see traffic between computers A and B, or B and C, or A and C. You're only going to see to and from the sniffer in this case. Now, that said, we just talked about port mirroring, where you can actually mirror traffic from one port to another. But if the NIC on a host, the network interface card, is dropping any packets not to or from your own host, then wouldn't it just drop all of the packets that are being mirrored from the other host? So if we're mirroring packets from the port that computer A is plugged into to the sniffer, wouldn't the sniffer just drop all those packets? Well, you're right. It actually would under normal circumstances. However, we have this option of promiscuous mode that actually helps us overcome that issue. Whereas the NIC would normally drop any packet not destined to the address that it holds. With promiscuous mode enabled, it'll actually take that traffic and go ahead and pass it along the chain so it can be accessed by the processor of the computer and processed by your packet sniffing application. That traffic can actually be seen and accepted instead of dropped at that outer wall that the NIC kind of has have set up for us. So promiscuous mode is what allows us to do this. And going into promiscuous mode is not too difficult. As a matter of fact, most packet capture applications include the ability to do that via a specialized driver. The two things you need to go into promiscuous mode are a network interface card that is capable of doing that and a driver that will actually enable that mode. Now, the good news is that most every modern network interface card is capable of promiscuous mode. I'm not sure I ever run into any anymore that just aren't capable of it. That was certainly an issue 10 years ago, but not an issue today. So you can rest assured that most of the NICs you'll encounter, at least wired network interface cards, will allow for promiscuous mode. That said, most packet capture applications also now come with drivers that will allow the network interface card to be switched into promiscuous mode. So Wireshark, if installed on Windows, comes with WinPCAP. Wireshark or TCP dump installed on Linux comes with libpcap, which is a driver that can be used to switch the card into promiscuous mode. So that is what allows us, when we're doing things like port mirroring, to look and intercept packets that were not necessarily destined for the host we're actually listening from. They kind of bypass that restriction that just drops those packets at the NIC and makes that possible. So I mentioned that here because it's useful to know in regards to port mirroring, and it's actually also relevant for all the other techniques we're going to discuss. It's relevant for hubbing out, it's relevant for ARP cache poison, and it's relevant for using a tap. So promiscuous mode, very important in that regard. We won't talk about promiscuous mode too much in depth as we go along in the course, but it's important to know it's there. It's important to know how it works and the role of things like WinPCAP or libpcap when you are asked to install them when you install tools like Wireshark.